let's continue on with this. We just did an example where we found a data value that was not exactly 1, 2, or 3 standard deviations from the mean. But we can find that. It's called the standard score, also known as the z-score, which we just use the initial z for, is used to find the standard score. Okay, so to find the z-score, we take the data value minus the mean divided by the standard deviation. If it's above the mean, it's positive. If it's below the mean, it's negative, because you're taking a large minus a small or a small minus a large. Now, if we know the z-score to calculate a data value, the data value is the z-score times the standard deviation plus the mean. Okay. So we're going to continue on using the information from the blood pressure problem. So we are going to use the formula to find the z-score for the blood pressures below, the 95 centimeters. We estimated it to be a half. Okay, well, if we look at this data, we know that the mean was 85 millimeters and a standard deviation was 20 millimeters. So if we want to find the z-score of 95, we know that this is our data value. So we're going to take the data value minus the mean divided by the standard deviation, which in this case the data value is 95, the mean is 85, the standard deviation is 20. That gives us 10 over 20, which is 0.5. If the data value is 61, then, and that's our z-score, our z is going to be the data value minus the mean. Notice this is below, so this should be a negative number, divided by the standard deviation. That gives us negative 24 divided by 20, which is negative 1.2. So that means 61 is 1.2 standard deviations to the left of the mean. So if we're given the data value, we can find the z-score, which is the standard deviations. If we're given the z-score, we can find the data value. So if we're given a z-score, we know we're going to take the z-score times the standard deviation plus the mean. We have all those values available. So it's going to be 2.3 times the standard deviation plus the mean, which gives us 131 millimeters. If the z-score is negative 0.8, it's going to be negative 0.8 times the standard deviation plus the mean, which gives us 69 millimeters. Okay. So if you will notice, the next page is a chart, and it deals with standard scores or z-scores and percentiles. So suppose we want to know the percent of people who have a blood pressure below 95. We are going to use the z-score and the table of percentiles that is given to you. So now how do you read this table? Okay. All right. For any z-score, which is any standard deviation, it will tell you the percentile, and this is the percentile the percentile here is the percentage of all data values that are less than or equal to it. Okay. So what that means here is if your z-score is 0, that means this is the mean. 0 is the mean. 50% of the data values are below 50%, or excuse me, are below the mean, and 50% are above. If your z-score is 1, 84.13% are below 1 standard deviation, and then you can find by subtracting 100 the amount that are above that. So let's just do some examples and see how to use this chart. Okay, so the percentile here is the percentage of all data values in the data set that are less than or equal to it. So let's find the percentile, or the percentage of people who have blood pressure less than or equal to the given values. Okay, so we're going to start out with 95, which has a z-score of 0.5. So if I do that, I'm going to find here a z-score of 0.5. So the percentile, where z equals 0.5, is 69.15, or 69.15% of people have a blood pressure less than or equal to 95. So the people who have less than or equal to the given value is the percentile on the chart. Now, to find the percent of people who have blood pressure more than 95, well, all people is 100%. So less than or equal to 95 is 69.15%. So greater than 95, we just subtract that, and it's going to be 30.85%. All right, for 80 millimeters, first we have to find the z-score for 80 millimeters. So to find that for 80 millimeters, to find the z-score, that's going to be 80 minus the mean, which is 85, divided by 20. which is negative 5 over 20, which is negative 0.25. If I look at negative 0.25 on my table, a z-score of negative 0.25, that tells me 40.13% have blood pressure less than or equal to 80. Okay, so let's see if we can apply this to something else, everything that we have learned on this. Okay, so here we've got the 2019 SAT math scores for Texas. They were approximately normally distributed with a mean of 507. Mean of 507. And a standard deviation of 107. So this is my mean. Then I have 1 standard deviation, 2 standard deviations, 3 standard deviations, -1, -2, and -3. Okay. So if I add 107, that gives me 614. If I add, so plus 107. If I add another 107, 2 standard deviations is 721, and 3 is 828. If I subtract, 1 standard deviation to the left is 400, 2 standard deviations is 293, and 3 standard deviations is 186. Okay, suppose you want to know information about Texas students who scored above and below 650 on the math section. All right, so let's see what we've got here. Let's see if we can figure out where we're even looking for. All right, so I know I've got my mean here of 507, and I'm going to do this sideways so it'll fit. And then I have 614 and 721. Okay. So, if I'm looking at above and below 650, well, 650 is going to be somewhere right in here. So here is my 650. So I want to know the percentile below, and I want to know the percentile above. So these are the two regions that I'm looking at. Okay, so the first thing I have to do is find the z-score. The z-score for 650. Okay, so I know the z-score is going to be the data value minus the mean divided by the standard deviation, and I get the z-score is 103. I'm sorry, 1.3. Okay. So, and that makes sense because this is 1 standard deviation, this is 2, so it's going to be somewhere in between there, which is 1.3. So I'm going to use my table, look up the z-score of 1.3, and I find that the percentile is 90.32. Okay. That percentile tells us the percent that scored less than or equal to 650 is the percentile. Then if I want to find more than, then it is going to be 100 minus the 90.32, which is going to be 9.68. So we used the data value to find the z-score, looked up the percentile on the z-score, which is the amount less than or equal to 650. Subtract that from 100 to find out more than 650. Now let's look at this a little bit differently. Let's say we want to look at more is in the 80th percentile. What does that mean? She got her score. The report said that it was in the 80th percentile. What does that mean? It means that let me phrase that a little bit. 80% of students scored less than or equal to her score. Now find the z-score. Now I know the percentile, but now I need to turn that into a z-score. So I'm going to look on here until I find the closest to 80. And the closest is 80.23. So the z-score is 0.85. So now I can find her score. I have to use the formula to find the data value is going to be, in this situation, the z-score is 0.85, the standard deviation is 107, and the mean is 507, and that gives me her score of 598. Okay. All right, so just remembering how to do all that, and knowing how to utilize that table is going to be key. Okay, suppose the heights of all men are normally distributed with a mean of 70 and a standard deviation of 4. Okay. So that means I have 70 here as my mean. So 1 standard deviation, I add 4. 2 standard deviations, I add another 4. 3 standard deviations, I add another 4. Okay. On the left, subtract 1, which gives me 66. Subtract another 4, which gives me 62. Subtract another 4, and I get 58. Okay. What percent of men have heights between 62 and 78? Well, now I'm going to have to go back to my first page here, and if I can find it. Between 62 and 78 is 2 standard deviations. So 62 and 78 is 2 standard deviations. And I know that everything under that curve is 95%. What percent of men have heights outside of this interval? So I would be looking at this part and this part, everything outside. Well, I know all men are going to be 100% minus the inside. So that's going to be 100% minus 95%, which gives us 5%. Okay, what percent of men are shorter than 74? Well, let's see. We know we have our 74 here at 1 standard deviation. So we want to know everything below that. So I'm going to have to break this up into 2 pieces. Well, I know this piece, since from -1 to 1, this is 1/2 of 68%, which is 34%. And I also know that since this is the mean, everything to the left of the mean is 50%. So I have 50% plus 34%, which gives me 84%. Okay. What percent of men are taller than 74? Okay, so I'm going to go back to my 74, but now I want to know above that. Well, I know from part D that this over here is 84%. So I'm just going to take 100% minus 84%, and that gives me 16%. Okay, what percent of men have heights between 58 and 74? Okay, well, 58% is my 3 standard deviations. So this is 58, and this is -3 standard deviations. 74, again, is 1 standard deviation. And once again, I'm going to split this up. This is half. The total under the curve is 68. And then all of this over here, this is 3 standard deviations. So this is 1/2 of 99.7%, which is 49.85. So my total is going to be 49.85%, excuse me, plus 34%, which is 83.85%. In a group of 600 men, how many would we expect to have heights between 58 and, this should say 74. Sorry about that. Well, we're looking at 83.85% of 600. So that's 0.8385 times 600, which is 503.1. I'm going to call it 503 men. Okay. So you can see how knowing that standard deviation chart is going to be helpful. Okie dokie. According to one publication, the average monthly cost of renting an apartment in Austin is $1,400. So that means this is going to be $1,400 with a standard deviation of 300. So that means this is 1700, 2000, and 2300. This is going to be 1100, 800, and 500. So this is -3 standard deviations, -2, -1. This is our mean. This is the symbol for mean. This is 1 standard deviation, 2, and 3. Okay. What percent of apartments in Austin rent for more than $1,700 a month? Okay, well, 1,700 is one equals 1 standard deviation. So I'm looking for this amount here. Well, what do I know? I know from here to here is 34%. I know from here all the way over is 50%. So this is going to be 50% minus 34%, which is 16%. What percent of apartments rent for less than or equal to 1,100? Okay, I'm going to do exactly the same thing here. This again, 1,100 is -1 standard deviation. So I know this is 34%. And from here all the way over is 50%. So it's still 50% minus 34%, which is 16%. All right, so what portion are between 800 and 1100? So I'm really looking for this portion here. Between 800 and 1100. So let's see how I'm going to get there. I know 800 is -2 standard deviations, and I know 1100 is -1 standard deviation. Well, I know everything from here to here is 47.5%. So 1/2 of 95% is 47.5. And I know this is 34%. So if I take 47.5% minus 34%, that gives me that area of the shaded region, which is 13.5%. Okay. All right. If the z-score is -1.2, what is the rent? Okay, so -1.2 is going to, let me do it in this color. That's going to be something like here. This is going to be -1.2 standard deviation. So I need to find the data value for that. It's going to be between 800 and 1100. Okay? So I know that the data value is equal to the z-score times the standard deviation plus the mean, which is -1.2 times the standard deviation plus the mean, which gives us 1,040. Whoops, there you go. An advertisement for an apartment complex states that the rent is in the 70th percentile. So what is the rent? Okay, if it's in the 70th percentile, if it is in the 70th percentile, I'm going to find the z-score from the table. So I'm going to find the closest one. Okay, the closest one actually is this one. So that tells me the z-score is equal to 0.5. So then I'm going to use this formula here. So the data value is equal to the z-score times the standard deviation plus the mean, which is 1550. Okay, if the rent of an apartment is 1950, what is the number of standard deviations? This is asking for the z-score. And we know that the z is equal to the data value minus the mean divided by the standard deviation. So that gives us 1950. Oh, I can't see. Sorry about that. 1950 minus 1400 divided by 300. And let's see what that comes up to. I don't have that calculated. So 1950 minus 1400 divided by 300, and that gives me 1.83. We'll just call it 1.8. If the rent is 680, what is the z-score? Okay, I'm just going to use that formula. So the z is going to be 680 minus 1400 divided by 300. And I get negative 2.4. That means it's between negative 2 and negative 3 standard deviations. Okay, the end.